Welcome to the Missing Digit Prosthetic Project. Our group is Katherine, Korn, Cole Davidson, and Jacob Lawrence. Now for a quick overview of our project goals. So the prosthetic should be able to pick up a cup. The user should have control over the amount of force the digit is applying to the cup. The user should also be able to receive pressure and temperature feedback from the prosthetic and adjust the use accordingly. For our concept generation of the attachment mechanism designs, we came up with three main designs: the wrist brace with support bar plate, the hand strap, and the fingerless hobo glove. Ultimately, our choice was the wrist brace with support bar plate because of its availability of space. For our concept generation of the finger design, we came down to three options: the bubonic design, the cable design, and the 6-bar linkage design. Ultimately, we went with the cable design due to its large range of motion and easy manufacturability. This is what it looks like. Following the selection of the cable design, the FEA analysis was performed. For the stress comparison, the max stress that was found is 2.85 GPa, located at the center notch where the wire would cross over. For the von Mises stress, the max stress calculated was 4,478 MPa. Here you can see that the design will not fail under tension with a compressive force being applied. Following the FEA analysis for the cable design, the actuator was selected based on our specifications and needs for this prosthetic. The final actuator that was selected is the XW430T333R due to its weight, torque, and other specifications. The temperature sensor was selected concurrently with the actuator. The final temperature sensor that we selected was the digital thermocouple MAX 31856 MUD Plus to be paired with the Type K thermocouple. This sensor was selected based on its highest rating compared to other temperature sensors. Following the temperature sensor selection, the force sensor was selected. The final selection was the FSR FlexiForce ESS 102. This was selected based on its very small size, along with its highest rating received. Now, let's take a look at the material selection. The inner material meant to mimic bone was chosen to be SPS 40% carbon, and the outer material meant to mimic skin was chosen to be silicone VMQ thermally conductive 40 to 70% mineral. Now, let's take a look at prototyping. This is the EMG used. It's responsible for processing movement from your muscles and control the finger movement with that data. The microcontroller takes input from sensors and tells other things such as the LED what to do based on the input from those sensors. This is the force sensor, which was hot glued to the tip of the prosthetic finger. Here we are attaching the circuit boards to a power source, and as we can see in a few seconds, the response is shown on the screen. These pads on Cole's arms are measuring his muscle movements, which will be used to dictate the finger movements in the future. As you can see, any movement that Cole makes with his arm changes the signal being displayed on the screen. Thank you for watching, and stay tuned for future developments.